Question is, the pole zero configuration of a system is shown below. The magnitude of the transfer function will be. So here he is asking for a pole zero plot is given here. So simply, and here he is asking for, so what is the magnitude of the system with respect to frequency. So if you observe the options, all are in terms of the frequency. That means option A indicates increase with the frequency, option B indicates decrease with the frequency, and then independent of the frequency, and option D indicates initially increase then decrease with the frequency. So these are the options given here. So first, if you observe the system, then we will go for the option. So here if you observe the system, there will be symmetric pole zero configuration here. If one pole is here and the symmetric zero is here, and one more pole is here and the symmetric zero is here. Now if you convert this into an open loop transfer function model, okay, so if you convert this into an open loop transfer function model, then that will get transfer function equal simply s minus 1 to s minus 2 by s plus 2 into s plus 1. Now this is the transfer function. Now if you find out the magnitude here, what is the meaning of magnitude? So if you take if you substitute s equal to j omega here, so what you will get minus 1 plus j omega and minus 2 plus j omega, because s equal to j omega, then 2 plus j omega and 1 plus j omega. Now we have to find out the magnitude. So magnitude of the transfer function is 1 plus omega square under root 2 plus 2 square means 4 plus again 4 minus, it will be 4 minus, because j omega whole square means minus 4 minus omega square, 4 plus omega square, right? So that by again 4 plus omega square 1 plus omega square, this will be under root. If you solve this, we will get simply 1. So the transfer function, the magnitude of the transfer function is simply 1. So from this what we can say, there is no term called frequency here. So that's why the option will be here, the magnitude of the system or magnitude of the transfer function will be independent of the frequency, because we got a transfer function equal to 1. Again I am repeating the question. First, here the question is given, so first I am converting into pole zero part, the pole zero location into transfer function model, and then I find out the magnitude by substituting s equal to j omega. Then I find out the magnitude. After finding the magnitude, we got a magnitude equal to 1. So that's why, so it will be independent of the frequency. So that's why we have to go for option C.
Here we have to find out the number of quantization levels from the given data. In order to find the number of quantization levels, we need to find out the signal to noise ratio in terms of the given parameters and equate it to 60 dB. Here the signal power which is equals to variance, that is sigma square, equals to expectation of x square of t equals to rx of tau at tau equals to 0, whose value is given as a square by 2, a equals to 6, 36 by 2, that is 18 watts. Whereas the noise power is given as del square by 12, whereas delta equals to step size equals to 2 into peak value in magnitude divided by L equals to 4a square 12L square. L equals to 2 power n, where n equals to number of bits by using those signal power as well as the noise power relations. We can get the SNR equation as follows. Already we know SNR equals to 60 dB. So if we apply log to the above equation, equate it to 60 dB, we will get number of bits equals to 10. Means quantization levels equals to 2 power n, that means 2 power 10. Here the option is D. Here we have to find out the entropy of the quantizer output, which is given as H equals to minus summation k equals to 1 to 4 probability of xk log base 2 probability of xk, where xk is representation level of quantizer. Since the quantizer input is Gaussian with 0 mean and a Gaussian density is symmetric about its mean, we find that probability of x1 equals to probability of x4 and probability of x2 equals to probability of x3. The representation level x1 equals to 1.5 for y, which is a quantizer input, plus 1 to infinite. Hence probability of x1 equals to 1 to infinite 1 by root 2 pi exponential minus y square by 2 dy equals to 0.1611. Hence entropy. Similarly, we have to find probability of x2, and after finding probability of x2, if we substitute probability of x1 and the probability of x2 in entropy equation, we will get 1.91 bits. Probability of x2 equals to 0.3389. Here options are A 1.45 bits, B 1.67 bits, C 1.91 bits, D 2.01 bits. Hence option is C is right.